Hello you guys, today we're going to talk about linear equations. So linear equation is an equation for a straight line. So a linear equation is an equation for a straight line. So the equation for a straight line is just y equals mx plus b. So y is just the y value on the coordinate plane. So if we have our coordinate plane over here, this is the x and this is the y. So this is where the x values lie and this is where the y values lie. So y is just that and m is your slope. So m is just the slope. So slope is just change in y, that is delta y, over change in x. So that means the change in y values over the change in x values. X similarly is just the x values on this line, on the x-axis. And b is the y-intercept. Remember, it's the y-intercept. It's not the x-intercept, it is the y-intercept. So this is an example of a linear equation. So this is an example. Because if you see here, a linear equation is an equation for this straight line. And back here we learned that the straight line's equation equals y equals mx plus b. And here we have x and y both are there in the powers of 1. X is in the power of 1 and y is also in the power of 1. So let's check out another equation. So this is also an example of a linear equation, and as you can see here, this really resembles the y equals mx plus b equation. So as you can see, y, and then we also have m is 2 over here, we have x, and b is 1 over here. So that's pretty cool. So now let's move on over here to plot this equation. So now we know y equals mx plus b. We know that because we have two variables, and these x and y are variables, and we know that it is a linear equation because x and y both have a raised to the power 1. That's why we know that it is a linear equation. So now if we plot this on the graph, so first we're going to have x. So say if x is 1 and if you put 1 instead of x in this equation, you would get 2 times 1 plus 1, which is 3. That's what you'll get. Whoops, I just did something wrong. Yeah, 3. That's right. So say next value is 2. So if you plug in 2, you would get 2 times 2, that's 4, plus 1 is 5. And then say you plug in 3. So if you plug in 3, you get 2 times 3, that is 6, plus 1 is 7. So if we try to plot this on this coordinate plane of 1, this is your x-axis, remember, and this is your y-axis. This is your y-axis. So x-axis 1 and your y value is 3. So that means you have your point somewhere over here. 2, 5. So that means our point is somewhere over here. And 3, 7. That means it's going to be somewhere up here, like over here maybe. So as you can see, as x changes by 1, y changes twice as fast. So as you can see, this is 1 plus 1 is 2, but 3 plus 2 is 5. So it's going twice as fast. And over here, 2 plus 3, again it's 1, and 5 plus 2 plus 3, my bad. 2 plus 1 is 3, and 5 plus 2 is 7. So you get it. And here, if we wanted to plot this line, and as you know, the y-intercept over here, the y-intercept is 1, because we found that, because we just learned about our equation. So if we plotted this line, because this is the y-intercept, it would cross it on 1 and go somewhat like this. So that would be your straight line. So as we just saw, there are many other examples in different forms of linear equations. So different forms are just like y is equal to 3x minus 6. That's also a linear equation. Another example would be y minus 2 equals 3 times x plus 1. Now this and this are kind of different, but they are still linear equations. So this would be the y is on the other side and the x is on the other side. Here everything is on the same side, which equals 0. So this could also be a linear equation, but there's no y in this, and this could also be a linear equation. So in a linear equation, variables like x and y, so if we have a linear equation, so variables like x and y cannot have powers like they shouldn't be in exponents. Like they cannot be x to the power 2, they cannot be x to the power 3, or y to the power 2 or y to the power 3. That doesn't make it a straight line. That goes to like x to the power x squared would be like a parabola, so that's wrong. We need a straight line, and for the straight line, one equation that you have to remember, is y equals mx plus b. That is the most important equation, and you have to remember that in linear equations. So what are not linear equations? If you're talking about these are not linear, so what's happening? Okay, so these are not linear equations. Remember? So I'm going to show you some examples so that you know that these are not linear equations. So the examples are, the first one is just y squared minus 2 is equal to 0. Now this is not a linear equation because you can see here that we have a square, and as we just learned that x and y cannot be squared or cubed or any other higher power. So this is not a linear equation. So we understand it's not a linear equation because of this, because it's a squared. A second example would be 3 root x minus y is equal to 6. Now root x actually means 3 x to the power half minus y is equal to 6. Now here you can see y is to the power 1, but x has a power of half. Here you can see x is at the power of half. So that means it's not a linear equation because of this variable x. So that's why it's not a linear equation. Now we have another example, which is x to the power of 3 by 2 equals 16. This is also not a linear equation because x is to the power of 3 by 2. In a linear equation, the only powers that can be possible are x to the power 1, x to the power 0, or y to the power 1, y to the power 0. Any other powers would result in them being not a linear equation. And if you're confused, x to the power 0 and y to the power 0 give the same number. X to the power 0 is 1, y to the power 0 is 1. Anything raised to the power 0 will always be 1. So yeah, now I showed you this equation, y is equal to mx plus b. This is called slope-intercept form. So this is called the slope-intercept form. So in here, your m is the slope, that is this, and b is the y-intercept. So that's it for this video. I hope you guys liked the video, and if you do subscribe to my channel and do like this video.